Hello, my name is Patrick Fleming, and today we will be going over constant velocity and Newton's second law. Where we'll start is force equals mass times acceleration, and how that goes into the final formula of Newton's second fundamental law for the final velocity of an object. As you see, we start with force equals mass times acceleration, and with some simple mathematics and integration, we can get to our final form. Our final form will be used in this video to predict the velocity of a foam roller from the initial velocity. How we're going to do this is with a program called Tracker. Tracker will get the velocity of my foam roller, and we can track its position over time. As you can see currently, our graph on the right looks semi-linear, something that a Newton's second law would spit out. We will have to show it with the predicted formula in a second. How we're going to model this velocity is with a computer program called VIDLE. VIDLE will take in equations, perform a while loop, and give us our basic form of motion. As you can see, this would be the motion of the object at constant time. VIDLE is very good for showing the velocity in one dimension or two dimension. Currently we're just using it for its one-dimensional purposes. And with the model, we can show the predicted value against the actual value. As you can tell, the predicted values for the end of our time frame are going to be higher than the actual values. And we will go over this phenomenon right now. The predicted formula states that the net force of the object is going to be 0. Basically, this will not change the final velocity, and the initial velocity will be equal to the final velocity in the end, which will give us this nice linear line. But what is actually happening in real life is we have a negative net force due to air resistance and also due to friction. And what this will do is slowly chip away at our final velocity from our initial velocity. So our velocity will start out linear, and it'll eventually go until it's 0 because of the friction and air resistance and the negative net force. So, what is incorrect about Newton's second law and our predicted values are the assumptions that I made to make this lab report, assuming that there would be 0 friction and 0 air resistance, made it so that the actual values were not close to the predicted values after a large span of time. If I did not set the orientation of the axis due to in Tracker, this would cause error in our values. If we were to flip the axes, it would just make negative values. So instead of a positive x-axis, we would have a negative x-axis. And could we have a force that would be equal to the negative net force, and to make our actual values equal to our predicted values? And I would say yes. This could maybe be a downhill or a small push, keeping the velocity equal to the initial velocity. So this would be plausible. Thank you for stopping by and listening to my lab report. I will see you guys next week.